Alright, today I'm going to show you how to get amazing quality using Google Slides with your print. I'm going to give you a practical demonstration of this, and then I'll show you how it works. When you get to the part of this video where it shows you how it works, it might be a little bit confusing, so I'd rather just show you the practical application of it first. That way you can, maybe if you're interested in the math of it, you can then go down that path. Alright, so here's the scenario. I'm at work. You know, I'm like, I want to make a very quick document, 8.5 by 11, and when I print it, I want it to look amazing. Okay? Now the problem with Google Slides is it's at a really bad resolution. The resolution is actually 96 dpi. Okay? So not good. Usually a standard print document is at 300 dpi. So I'm going to make this page setup custom. Let's just demonstrate that. 8.5 by 11. Sweet. You notice the measurements at the top, 8.5 by 11. It says 8.5, right? Or 8.5. If I went to go to page setup, you notice in pixels it's like 812 by 1056. So 8.5 is now that in pixels. Alright, so we want to up the quality. If I went to print anything, let's say I made 1/4 of an inch go to format, go to size option. If I made like a 0.25 shape, 1/4 of an inch shape. If I went to print this out, it would be highly pixelated. So how do I make it so it's got good quality? Any of the type, if I put type out here. How do I make that good quality? Well, here is how you do that. We need this to be 300 dpi, so we take 8.5 times 300. And then we go back to a pixels and we type in 2550. Okay, we know it's going to be 11 inches, so we take the 11 times 300. Now we get 3,300 pixels. Sweet. So if we went to print this document, you're going to find it's huge. It's absolutely huge. It's a big document. So you have to go to more options and you say fit to paper. And since normal copy paper is 8.5 by 11, it will print at the 300 dpi at 8.5 by 11. We as printers don't like this fit to paper. This is only a hack if you're using Google Slides, which is a rare occurrence, but it just happens to be the case right now. And if I went to print this, it will be 1/4 of an inch. I did a test of this. There you go. So I went to print it out. It's 1/4 of an inch. Good quality too. Bad photo. Alright, so you have to kind of do all your measurements ahead of time before you upscale it, unless you want to do some math. So I'll show you how to go backwards a little bit without the fit to page option. Alright, so now I need another shape for this demonstration. This is not necessary, but this is again for educational purposes. I need this to be a 1/2 inch. Okay, so I'm going to show you how to, in the the next part of the video how to get this number. So 0.5 times 312. You got to put a point here in your head. So 1.56. 1.56 by 1.56. So this is going to be a ½ inch now. And you'll know that the same stands true with 0.25. Let's say I needed to do 0.25 times 312. It's 0.78. So I'll just throw another shape in here. As long as you know that 312 using Google Slides, you're fine. So in this case, I need to make it 0.78. Sweet. So if I went to print this using fit to page, it would be accurate. This would be a ½ inch and this would be a ¼ inch. Again, I would do all your measurements first before you upscale it and add photos. But that's how you go backwards. And just to test that out, I did take another shot. Here, the ½ inch one. And you can kind of see here in the photo where this is a ¼ inch. Alright, so if you ever need to make a very nice high DPI document using Google Slides, that's how you do it. Now I'll show you how to do the math on how to find the magical 312 number that I came up with. It would only be relevant if you are using Google Slides a lot though, and if it just bothered you how I came up with that number. Alright, so I hope you enjoyed the rest of the video. Alright, today I'm going to show you how to manipulate Google Slides in order to make a proper 300 DPI document and still use that new 300 DPI document with good measurements. Okay, I'm going to try to explain that. If you went to print a Google slide, you might find that it is rather ugly, okay, because its native resolution is 96 pixels. So first we have to kind of figure out how to find its native resolution. Yeah, I'll show you that first. So if you make a new Google slide and you go to page setup and you make a 1 inch by 1 inch document, you'll find that in pixels it's 96. Okay, 96 pixels. Good. So we've accomplished that. We know its native resolution. How can we use that? Alright, so I'll give you a practical problem. I need to make 8.5 by 11 document. So if I went to go, like typing on this, and if I went to go print it, it would look okay, but not the best, because it's only 96 pixels per inch. Sweet. So we want 300 pixels per inch. So for that to occur, we need a calculator. So let's go get a calculator. Alright, this is how you do the math for that. We need a 300 DPI document, right? 8.5 by 11. So 8.5 times 300 is 2550. Okay, so we do that. We go to page setup. We switch it over to pixels and 2550. Good. Now we'll do that to the 11. 11 times 300. And we'll get 3300. Sweet. So now we have an 8.5 by 11 document that is 300 dpi. You'll notice though, if I make a shape out here, here's 8.5 by 11. So what it does, it upscales your resolution by upscaling the document. So this document is not 8.5 by 11 anymore. It's actually 2656 by 3438. Cool. That is what it did. It upscaled it. So if I was to ever try to make margins, for example, let's say I wanted to make a 0.25 margin around this thing. You'll notice that 0.25 margins, you can't use scale anymore. You can't use measurement. Even though this is 0.25, you can't use that because this is a new upscaled document. It didn't do 8.5 by 11 by 300. It took the 300 and made a bigger document. That's the issue. Now, there is a solution for that. There's a way to use this, right, and still get proper measurement. And that goes all the way back to the 96, the native resolution of this. Because that is a weird number, usually it's like 72, 150, 300, something like that. But since it's 96, we have to do some crazy math, but not too bad. So we're going to go back 96 by 96. So the 96 1 inch by 1 inch diagram. All right. So what we do, because 72 dpi is kind of like what we're used to. Okay, usually there's 72 dots per inch. Knowing that, we first get its native resolution. Okay, 96. 72 is usually the norm. So we take 96 minus 72 equals, and since it's a square inch, we have to divide it one more time by 2. So divide by 2 equals 12. Nice. So now we have to add this to our resolution. 312 is our magic number, and here's how you use that. Okay, so if it's 1 inch by 1 inch, easy. We'll make a 0.25 by 0.25 square, and because this is using its internal, the ruler is correct, this is correct. If I print it, it's going to be a 0.25. Everything's correct, but again, if you print it, the quality is going to be horrible. So if I was to upscale this resolution to 300 by 300, quality is better, but you notice the 0.25 square is now 0.78. Why? Well, let's take our number. 0.25 times 312. 78.78. You got to put the point there. So that is that magic number. It's a really cool kind of number to know, and here's the practical way to use it. So let's say I make another square at our new cool resolution. I want it to print correctly when scaled down to a given ratio. I need it to be a 1/2 inch when it does print. Okay, sweet. So we take 0.5 times 312 equals, put the point there, 1.56. 1.56. There we go. So there's 1.56. Let's test it out. If I scale this back down to 96 pixels instead of 300, will it stand true? Okay, there we go. 0.5. And is this one 0.25? Correct. Alright, so that's the end of the second part of this, or second half of the video. I just wanted to show you how I came up with that number, how I was able to figure it out. And there was this kind of a slight show of an example of what the problem was. So if that helped you, enjoy. It works with any program, mind you. So let's say if you had a weird program that's online and you had to figure out the native resolution, you figure out the native resolution first, and then you take that resolution, you compare it to get the 72, which is normal, 72 dots per inch, and then you can do the math that way. But it's a very rare thing that you need that math. I've never come across another program other than Google Slides that I needed to do that. But there it is, just in case you wanted to know how I got the 312. So I hope you enjoyed the video. Have fun.